Hi, welcome to my video on solve equations. That's exponential equations, and this is extra equations at the end of the unit. Number one, find the zeros of the h of x equals negative 15 bracket base is 5 raised to the x minus 6 divided by 3 plus 15. The zeros is when you let the h of x equal 0. So that means that a negative 15 base x minus 6 over 3 plus 15 equals 0. So the zeros of a polynomial, the zeros of an exponential function in function notation is what we call the zeros. So if this equation, if this was equal to 0 like this right away, then we would be finding the roots of the solution. So negative 15, 5, x minus 6 over 3 equals negative 15. We move it over and make it a minus. We divide both sides by negative 15, and they cancel, We get 5 to the x minus 6 over 3 equals 1. And the base is 5, and since it's an exponential, then we need a 5 here. So 5 to the what power gives me 1, so the answer is 0. So that means x minus 6 over 3 is equal to 0. So since we have a fraction here, let's put the 0 over 1 cross multiply. So 1 times x minus 6, 0 times 3 is 0. So x equals 6, moving it to the right. So 6 is the 0 of this polynomial. Number 2, notice we have the h of x equals 3 to the x minus 2, f of x equals 27 to the x, the p of x equals 1/9 raised to the x plus 1. So it says the f of x is equal to the h of x times the p of x. Find the value of x. So the f of x is this function here, so we'll put 27 to the x there. The h of x is equal to 3 raised to the x minus 2 times the p of x, which is 1/9 raised to the x plus 1. So we have to find the value of x, and these are exponentials. So I notice that the base is 3 here, so 27 is a 3 cubed. So we'll change 27 to 3 cubed. That's already base 3. And 1/9, let's do 1/9 is 1 over 3 squared, which is 3 to the negative 2. So now we have each one of them in terms of the base 3. And now we have a power of a power, so we multiply. So this 3 to the 3x equals 3 to the x minus 2. And this is a power of a power, so we multiply negative 2 times x, negative 2 times 1. And we have the same basis, but we have a multiplication here, so we 3 to the 3x. And because we're multiplying, we add the exponents, so it's x minus 2, add on negative 2x minus 2. And we have the left side is already base 3, so this is a base 3. So we add, we get a negative x minus 4. So we have an exponential equation with the same base as a base 3, so that means 3 to the x equals negative x minus 4. And we move the variables to the left side, make the x positive. Add, we get a 4x equals negative 4. Divide by 4, and we get x equals negative 1. So when you have x equals negative 1, this expression will be true. Again, just a review of the exponential rules and solving exponential equations, just a review at the end. Now, number 3 says solve for x, and we have again exponentials. Notice the base is 4 here. We could make it 2's, but let's just leave it at 4's. So this is 4 to the x equals, and change 1/4 is 4 to the negative 1. Again, I could have went with 4 is 2 squared, but because this is a 4 and this is a 4, I'll leave them in base 4s. So now we have a power of power, so we have to multiply. So 4x times x is x squared. X times negative 1 is negative x. And again, we have a power of a power, so we multiply to get 2. Negative 1 times negative 2. Since the bases are the same, that means x squared minus x equals 2. Notice now we have a quadratic. And when we have a quadratic, we make it equal to 0. So we move the 2 over to the left and make it negative. And this quadratic is, let's see if it's factorable. If it's not factorable, we use the quadratic formula. So to get x squared, we have an x and an x. The factors of 2 are 2 and 1. The product is negative 2. The sum is negative 1. So we need a positive and a negative to get the negative 2. Sum is negative 1, so negative 2 plus 1. Multiply, negative 2. Add, negative 2 and 1 is negative 1. So that means we have 2x minus 2 is equal to 0, or x plus 1 is equal to 0. X is equal to 2, or x is equal to negative 1. And again, sub these in to check to see if they work out. And just for a bit of fun, let's check x equals 2. So 4, 2, 2 minus 1 equals 1/4 to the negative 2. 1/4 is, that's 4 to the negative 1 to the negative 2. So that's 4 to the 2. So that's 16. And right here we have 4 squared. 2 minus 1 is 1. And we multiply, we get 4. 2 times 1 is 2. So that's a 16. So we checked. X equals 2 is okay. X equals negative 1. So 4 squared. Negative 1 now. What am I doing? That's a negative 1. So x is negative 1. And again, we know what this comes out to be. We worked it out here, so that's a 16. So that's negative 1. So that's 4 to the negative 1. Negative 1 subtract negative 1 is negative 2. We have a powers of a power and multiply. So that gives us a 16. So that's true. So these are two solutions. Number 4, solve for x. Again, we have two equations, but we notice we have x's and y's. So if we take, this is equation 1 and this is equation 2. So we take the first equation, and notice the first equation has basis 5. So that means we change 25, change our 25 to base 5, so that's 5 squared. So that means x plus y equals 2. Now we'll deal with equation 2, 3 to the 2x plus y equals, and the base is 3 here, so we need a 3 here. So this 1 over 27 is 1 over 3 cubed, which is 3 to the negative 3. So 3 to the 2x plus y equals 3 to the negative 3. The bases are 3, so that means 2x plus y equals negative 3. If you have a exponential equation with the same bases on each side, then exponents are equal. So that means that if we take this equation, we have two variables, so I'll write them down below each other. And now I want to eliminate, so I multiply by negative 1, I'll eliminate the y's. If I multiply this by negative 2, I'll eliminate the x's. So let's multiply this by negative 1. Negative x minus y equals negative 2. Multiply this one by 1, and we get 2x plus y equals negative 3. and draw a line. The y's cancel out, so x is equal to negative 5. And just, okay, now we'll sub in. So we have equation x plus y equals 2. So what we'll do, we'll sub x equals negative 5 in. So x is negative 5 plus y equals 2. Y equals 2 plus 5. Y is equal to 7. So we have a solution that x is negative 5 and y is 7, or we have an ordered pair of, if they intersect, we could have that. But let's just check to see if we're right. Let's check to see if this works out. So we're going to check with one of the equations. So let's check with this equation here to make sure that, or wouldn't make a difference. Let's check with number 2. We plugged it in number 1 here, so let's plug it into number 2 to check. 3 to the 2x plus y equals 1 over 27 to the negative 1. So we know we have this, we worked this one out to be a negative, that's 3 to the negative 3, and that's 3 to the 3, so that's a 27. So x is negative 5, so we got 2, negative 5, head on to y, which is 7. So we got 3 to the negative 10 plus 7. So that's 3 to the negative 3. So that's 1 over. So I checked it out. Good thing I did, because I don't have the same answer. So I had to go back through and check to see now. That's 3. Oh, right here. Now, that's true, but I forgot to put the negative 1 in. So negative times negative is a positive, so that's a 3. So because I forgot to put the negative 1 in, I have an error. But by checking, I know that these are not the solutions. So now the equation is that 2x, that's equal to 3. And so that's a 3. And if I add now, I get a 1. So x is 1. So I'll put a 1 in the place of x. So let's scratch that out. So let's go x plus y equals 2. And we got x is 1. 1 plus y equals 2. Y equals 2 minus 1. Y is 1. So I have x is 1 and y is 1. So it's a good thing we checked, because I forgot to take the negative 1 right here, write it down. I would have got a positive 3. I would have been okay, but I didn't. I made an error. So checking, make sure that it worked. Notice I didn't sub this value into here, because I already worked out this one. So if I sub it into the other one, that verifies. So okay, so the answer, x is 1, y is 1. Let's continue. Number 5. 2 to the a equals 1/8. X equals 3 to the negative a plus 1. Find x. Find the value of x. Well, x is here. In order to get x, I need the value of a. So if I take this equation, which is 1, this is 2. So if I take equation a, or equation 1, and work it out for a, so that's an a. 1/8 is 1 over 2 cubed. So 1/8 is 2 to the negative 3. So that means a is equal to negative 3. So I'm going to sub a equals negative 3 into number 2. So x equals 3 to the negative a plus 1. So x equals, a is negative 3. So negative 3 plus 1. 3 to the 3 plus 1. 27 plus 1 is 28. So notice I have to solve this one for a and sub it in here, and that will give me my x. And the last one to do, solve the system. Solve the system means find the values of x and y. Notice both equations we have these are parabolas, or I should say they look like parabolas, but their exponential equations equal to each other. So one way to solve is algebraically, but I wouldn't want to graph these. It is best to solve them algebraically. So since two equations are equal to y, but I just said a parabola, but remember a parabola is y equals ax squared plus bx plus c. So that's a parabola, but these are exponentials. So we let, this is equation 1, this is equation 2. So I'm going to go 2 to the x plus 3 minus 5 equals 1 half to the negative x minus 1 plus 7. So how am I going to solve? I have to, notice I got a base 2 here, and I got a base, this is base 2 because it's 2 to the negative 1. So let's group the bases together like this. And 7 plus 5. That's 2 to the x plus 3 minus a half is 2 to the negative 1 equals 12. So that's 2 to the x plus 3 minus, this is power of a power, so I multiply, negative 1 times negative x is x, negative 1 times negative 1 is 1. So I have the bases on one side and the number on the other, so how are we going to continue? So this is, this rule right here is that if you have a base to an x plus y, well, that came from x just reversing. So b to the x times b to the y is b to the x plus y. So that means that I'll reverse it. So that's 2 to the x times 2 to the 3. This is 2 to the x times 2 to the 1. So notice that 2 cubed, that's an 8. Notice here, I have 2 to the x times 2. So that's 8 times 2 to the x minus 2 times 2 to the x equals 12. And because they're like terms, 8 minus 2 is 6. 6 times 2 to the x equals 12. That's like an 8. So if you look at that, 8y subtract 2y is 6y. So 2 to the x, I could have taken it out. So now I divide by 6. So 2 to the x equals 2. 2 to the x equals 2 to the 1. X equals 1. So if x equals 1, and another way, I just want to look at another way here. I could have done it right here. I could have done, I want to just drive this home right here. I could have said that was 2 to the x is common. So if we take that out, you get 2 cubed, subtract 2 to the 1. So I could have factored this, because 2 to the x is common. That would give me 2 to the x, that's an 8 minus 2. So that's 2 to the x times 6. So I could have done it that way, but I elected to add these together. It's the same as doing this. So x is 2, so I'm going to x is 1, better be careful, sub 1 into, sub x equals 1 into number 1. So y equals 2 to the x plus 3 minus 5. So x is 1, better be careful. a 4. 16 minus 5. So y is 11. So x is 1, y is 11. Or I could also state it as, to solve the system, it's an ordered pair, which is x is 1, comma 11. So that's x and y is an ordered pair. But the solution, x is 1, y is 11, solves the system for x and y. So that's an extra few equations that I wanted to work out to do with exponentials. And again, these are exponentials because x is in the exponent. These are not a parabola. Parabola is y equals ax squared plus bx plus c. So I said a parabola, but I just wanted to explain again. So that brings us to the end. And if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that I have on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.